Hello all and welcome to my YouTube channel. So today in this particular video, we're going to discuss or talk about a particular technique called explainable AI. So in this particular technique, we are generally explain the trained model on the particular data set. So when we train a particular model on a particular data set, the model try to learn upon that data and gives a respective output. So if you see on the screen, we give an input to this particular model and it gives an output. But the thing is, we are unable to understand, or we are not able to understand like what the model is being learning inside, like which features it is being calculating more, like on which feature it is focusing more, and which features are contributing it to the output predictions. So likewise, that kind of thing we are not able to understand from the model training. So to explain such kind of things, like how the output or how the predictions are being printed out with that model, so we generally use an explainable AI. So there are varieties of explainable AI tools. So we are going to explore one of them, which is called Sapash. So this Sapash tool will help us to understand like what is happening inside the particular model to explain the particular predicted output. So in generally, when we train a particular model, the users or the business team generally ask like what kind of features are being included and what feature is more important towards the predictions. Such kind of answers we need to provide. As a data scientist, you have to provide such kind of answers to the team, and you have to explain like which features are being contributing more to the prediction side and which features are not, and how to interpret more of the things from the features when you get such kind of interpretations from the model. So for interpreting such kind of things, we have to explain, or we have to give in particular importance to the explainability of the model. So such kind of things can be achieved using varieties of tool. So one such tool I have already explained on my YouTube. So if you go on to my YouTube and you can search my channel with Karndeep Singh, and you can mention Shap over there. So you're gonna get a uh, uh, particular video on the particular explainable AI tool, which we call as Shap. So if we go into this particular my channel, and you can find this Shap video, which I have explained it already on the deep learning model. So this is one of the tool, and today we are going to discuss another tool which we call as Shapash. So this Sapash tool basically internally it uses Shap tool only. So it's just an overlay over Shap, and we are going to use it to interpret in a better way, to demonstrate in a better way, to present it in a better way. So this tool help us to integrate everything at the back end, and we can also integrate Lime tool, which is one of the which is another tool help us to interpret the things. So this Shapash tool can be integrated over all over those tools, and we are going to use this Shapash tool to make the things very clear and very easy. As well as this particular Shapash tool also help us to make a web API, so that we can visualize the things over the dashboards. So you can see in the Sapash tool, we have a lot of things to be coming up. So you can see there are a lot of graphs and charts are being showing up. So these all things can be viewed over the dashboard that Sapash tool provides. So Shap, Lime, and these two particular tools are being used inside this Sapash. So, but by default, you have to that Sapash tool uses is a Shap tool. So you can switch it to the Lime as well while taking up this Shapash. So this Shapash is just an overlay over these particular tools, as this help us to visualize these things very properly. And you can see it has also a dashboard which can help us to understand the things very clearly in one particular window. So this is all the Shapaz has, and it integrates with the production environment as well. So we'll look upon to this, like how we can use it in the production as well. So let's jump onto the notebook and see how this things works. So uh, so to work with the Sapash, we have to first install this Shapash, and once you're done, uh, we have to import the necessary things. Since I have already installed this Shapash, so it is showing requirement already satisfied. So once the installations are being done, you have to import simple libraries from pandas, from sklearn. So we are just trying to train a model over here, and we'll try to understand the internal things, how it is going to learn and understand while predicting the things. So here, for training a model, we are using sklearn, and we are going to import a random forest regressor, and we are going to use train test split and normal pandas and random imports are being done. And from Sapash, we are going to import smart explainer. So this smart explainer will help us to uh, explain the model, whatever the model we are going to train. So here we are going to train a random forest regression model. So it will explain this smart explainer will help us to explain this trained model. So we'll look upon to this. But for the import part, this is all we need to import it from the Sapash and the required necessities. So once that is done, we are going to load the data set. So here I am going to use a very famous data set, that is wine quality red data set. So let me just import it, and we have to specify this particular label also, like which is a target label, and which are the features that we are going to use as an independent label. So let's just run this particular cell, and let's just visualize the data frame. So you can see we have so many columns, and at the end, this is a quality column, is that what we are looking for. So this is a target column for us, and we are going to train up a random forest regression model over this particular data, and we'll try to predict this quality. And after that, once the model is getting trained, we'll try to see which kind of features are being important, which features are contributing more, which features are contributing less to this particular prediction outputs. So for that, let's just let's just split the data set in train and test. And so we'll split the data set into train and test in this particular cell. And then once that is done, we'll import our random forest regression. We'll give some few hyperparameters, and then once that is done, we'll train a simple model on this particular data set. So once the model is trained, we can predict the output by using model.predict on the test data set. And we are going to reframe this particular output as a column as prediction. So we'll just run this particular set. So you can see this is the predicted output from the trained model. So once this training the model is done, the prediction is done. Now the Shapash comes into play. So we want to explain this train model, right? So for this, we have already imported this smart explainer above, and we are going to use this. So once we call this particular class smart explainer, we have to compile the particular test data and the model that we have trained over here. We have to pass this particular model, and we have to give this particular test data and predicted data. So you are giving this predictions output also. So you can see we are passing three entities right here, three parameters, and we're compiling it. So this compilation will help us to learn the things that is from the test and the predicted output, and the from the model. So let us run this, and you can see that it is using Shap at the backend, but it can also be changed inside this explainer. You can also change it to the line contributions also. So by default, it is using Shap as a backend to explain the particular model or interpret the model predictions. So once this compilation is done, we can use a web app. We can directly run a web app, and we can see the output in a better way in a particular dashboard format, right? So for that, we have to run this particular run underscore app from run underscore app uh, method from this particular XPL that we have imported over here, and we can just run the particular app. So let us run this particular cell, and we can see uh, it started running on this particular local server. So let's uh, run this particular local host, and let's visualize the things, which kind of features are very important to the model predictions. So you can see model has learned few of the things from this particular smart explainer. So we are visualizing this particular things, whatever it has compiled and whatever it has learned over here, and we are visualizing it here in this particular dashboard. So you can see this is a, on the right hand side you can see that this is data set what we have given. So this is a test data set, and this is the feature importance, and it is, you can see here the contribution of each and every single importance, like for each and every feature what is the importance. So individual importance contribution is also being shown over here over the prediction output. And you can see here we have local explanation. So that means if you select any row, so it will show the prediction, it will show the explanation for this particular row. So you can see id number 29, you can see we have selected 29, 29th id, so it is showing the prediction and what is the interpretation of those particular row on this particular model. And here you can see there are various parameters. You can see we can provide the threshold to give an predicted output of required threshold, and you can also restrict to the prediction display, like what are the features you want to display and what features you don't want to display it. So right now I have set it to 3, so you can see 3 features are being shown, and if I select it to 9, so all the features are being selected. So likewise you can see it, and here you can see positive and negative contribution. So we'll come into this, but before we see this particular feature importance, so you can see uh, each features how it is contributing towards the prediction of this particular model. So you can see alcohol, sulfate, and so likewise we have this particular feature importance, right? So if you click on this particular sulfate, this individual sulfate column predictions contribution is being shown over here over the prediction, right? So you can see this predicted output on this particular cell, like what is the quantity and how it has been predicting and what is the contribution of this sulfate. So you can see id 165 is contributing, is predicting 5.17, and its contribution is negative, you can see minus 0.4424. So this particular id is contributing, this particular row 65 is contributing negatively. And if you go at the top you can see the row number 965 is contributing positive at 0.22. And if you see at the top, it is the orange ones, these are highly contributing part, right? So you can see this kind of predictions, and you can understand which rows and which particular part of the data is contributing more. So this is related to the feature sulfate. Likewise if you click on this particular pH, so this pH contribution will start showing up, and likewise you can analyze the things. So this is how the feature importance and this individual contribution is showing up. And then you can also go and explore more onto this, like let's suppose I want to check upon this onto this particular row, like 70th row, and I want to understand the prediction part of it. So if you go and click onto this, you can see on this local explanation part, this id number 70, that is row number 70 is being selected, and its predicted output it is also being shown over here. And you can see there are various columns that is showing up, like which is contributing positively and which is contributing negatively. So you can see here pH and sulfur dioxide is contributing positively, and volatile acidity and sulfates and alcohol are contributing negative. So likewise you can check out the things like which particular row is contributing more onto this prediction, and which type of columns are being contributing more over to this predictions. And from here tableau data, or from here dashboard, from this dashboard you can check onto this particular positive or negative. So if you want to show the only the positive one, so you can click on this positive, and only the uh, positive contributions are being shown. And if you uncheck this particular positive and check this particular negative, then only the negative predictions are being negative contributions are being shown away. So likewise you can show and present the things. And here you can see there, uh, you can take a screenshot of this, and you can save it as an png format. So this whole feature importance thing will be saved as a png. Similarly you can click it over here and you can save it, uh, and you can explore more over this. So likewise you can check the explainability of the model with respect to each features, and with even respective to each row, and it shows the contribution factors, and it also provides some parameters to play with on the threshold side and the on the display feature side of the number of columns. So this is what uh, the flexibility that Shapash provide, and this is how you are able to uh, explore the things. So these all values that is being produced over here is all being provided by the SHAP SHAP library. So at the backend, all over the calculation that is being happening to learn these particular predictions on the future importance side. So these all things are being calculated using SHAP values. So for more information, you can go onto the SHAP site, and you can understand how these things are being calculated at the backend. So SHAP values are being used over here to predict the future importance and predict the future contribution of the particular columns, right? So this is what we have in Shapash. And then once you're satisfied with this particular analysis, and you want to go and further uh, save this particular analysis into your particular local system. So before saving into that particular system, you have to stop this particular web app. So for that, you can just provide app.kill command. So you will run and it will kill this particular web app. So once that is done, you can also export whatever the analysis you saw on that particular dashboard. You can export it into the pandas. So with to export into the pandas, you can just uh, 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 use the method called xpl dot to underscore pandas, and you can just provide maximum three. That means the top three most contributing features. So you can also provide nine or three, like whatever the analysis you want. Or suppose you want to have only max three features that is contributing to the particular prediction, so you want to just take the summary of it and save it to the data frame, so you can do that as well. So for that, we are using this particular method, and let's just visualize this. So you can see we are using three top three features. So you can see alcohol was the first features that was contributing more to the prediction, and sulfates was the second, and third was volatility exit. So likewise, we can save this particular analysis over the data frame, and once that is done, we can save this particular smart explainer object into the pickle form, so that we can use this analysis again and again for the later scenarios as well. So for that, you can just do that as xpl.save, and you can save it in this particular pickle format. So you can just, if you run this, you get saved xpl smart explainer in the form of pkl, that is pickle format. So this is all about the smart explainer concept, and this is how we train, explain the model, and this is how we save the smart explainer. But let's suppose if you want to do everything in production, so how you gonna do it? So for that, we have a different explainer, which we say it as smart predictor. So from here till now, we were just explaining this model. So once this model has got explained, that everything has been understood, now we want to switch it to the predictor side. So from here, we'll switch this smart explainer to smart predictor. So because in the production side, we will receiving the test data, or that means the new kind of data. So at that point of time, we will use the prediction, right? So we'll take this new data, we'll pass it to the model, and we'll get some predictions. So for that kind of predictions in production level, want it to be explained, right? So for that, we are going to use smart predictor here instead of smart explainer. So smart explainer was for the training part, and now we are going to use this smart predictor. So so from there, we'll switch it to the smart predictor. So to switch it from smart explainer to smart predictor, we'll just have to use a method called to underscore smart predictor under xpl. So once we'll run this, it will change it to the smart predictor, and we'll save this predictor in a pickle format. So we'll just save this into particular pickle format, and then we'll load this particular predictor. So how this can be done is it can be done using this particular class from the particular Spash. Sapash, right? So we have to import it from the Sapash that loads predictor, and we'll load this particular saved pickle predictor from the pickle format, and we'll load into this particular predictor load variable. So So once we have loaded the splitter underscore load from this particular pickle file, so we have to just provide a new data set to this particular splitter load method. So because we want to print it on the new data set, so we have to provide this particular data to it, new data to it. So what we're going to do is we are going to just pass it to this particular data to this particular splitter load by using this particular method that is called add underscore input. So we'll provide this data, and that is x, and we'll try to say that we'll want to print this particular output in this particular y print column name, right? So this output is going to print it here. We'll just add it, and once that is done, we want to load up the predictions from this particular y underscore pred, sorry, or y pred. So for that you have to just use printer underscore load, and you have to extract this particular y pred from this particular data. You have to print this printed output. So you can see we have extracted the predictions from this particular printer underscore load to this particular predictions, right? So once that is done, we'll able to explain this particular predictions from the data. So we're going to use this particular explanation by using this detail underscore contribution method from the predictor underscore load. So we'll just use this detailed contribution from predictor underscore load to understand the explainability of this particular prediction. So let's run this particular cell to see the predictions of this particular model. So, and how this particular predictions are being used, or how it is being predicted by using the particular features that that we are using. So you can see each and every column is shown over here, and each and every column's contribution is shown over here for each and every prediction. So you can see it's a detailed contribution towards this particular prediction, and that's how you can analyze and visualize the things using Sapash. And this is being done in the production level. So all these things, this particular explainable AI is being used in the production level to explain the model interpretability over the trained data, as well on the new data that is being coming over to the model. So this will be helpful in the production level to understand the model better, and it will help us to understand which features are being contributing time to time, and that's how we can focus more on the feature part, like which feature has to be removed, features has to be added, or what kind of the data that needs to be prepared in future. Like if suppose today this feature is being helpful for predicting today's scenario, but in future this feature is not contributing to the prediction scenario, then we have to check this particular explainability. So this explainability will help us to understand such kind of scenarios, and it will help us to analyze continuously like which features are very important towards the prediction of this particular objective. So I hope you understand the interpretation of this particular Sapash, and how this can be integrated into the production, and how we can utilize this particular library for our use case. So I hope you enjoyed this video. If you like my efforts, please do subscribe my channel. Thank you.